Hello, so this is the video that I said I would make because a lot of you guys were wondering. So I'm going to try explaining it as thorough as possible without unnecessarily yapping. But yeah, okay. So this problem, you can do it the fancy way of converting to base 10 and converting base 2. The reason I don't like that is because you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 to the ninth. And then which is like 512. So I guess you could add and it's not terrible. But another way you can do it is identify that, hey, a couple exponent properties. First of all, base 16 is equal to 2 to the 4th, right? Another thing is that like if I represent this as 1 times 2 to the ninth, 2 to the, like if you use exponent properties, first of all, 2 to the a times 2 to the b, that's 2 to the a plus b. Similarly, 2 to the a to the b is 2 to the a times b. So that's pretty nice. So 2 to the ninth, I'm actually going to write in terms of 2 to the 4th. So first of all, I could do 2 to the 4th times 2 to the 4th times 2 to the 1st. And that's still 1 times that, right? The reason I want to do that is because now look at this. I can just write that as 2 times 2 to the 4th squared. And we have to, and anything, like, if we have x in base 16, that's like, for example, like, I don't know, like a times, like, 16 squared plus, like, b times, like, 16 to the 1st, right? So, if we write it in terms of 16, or 2 to the 4th, which is just 16, we can just get our translation pretty, our conversion pretty quick. So now, that's the first term. So, if you remember, this entire thing is just equal to 2 to the ninth plus 2 to the 8th plus 2 to the 7th plus 2 to the 6th plus 5, 4, 3, 2 to 3 plus 2 to the 1st. Yeah. So, now we have this next term, which is just 1 times 2 to the 4th squared, because 2 to the 4th squared is 2 to the 8th. Now, for the third one, we can't write it in terms of 2 to the 4th squared. But what we can write it is just 2 cubed times 2 to the 4th. So that's just going to be 2 cubed times 2 to the 4th. Similarly, 2 to the 6th is just 2 squared times 2 to the 4th. And then you just have, like, and I'm actually going to write it out just so you guys can see what it looks like. 2 cubed, that's just 2 cubed times 2 to the 4th to the 0th plus 2 to the 1st times 2 to the 4th to the 0th power. Now, we can combine like terms. If I have 2 of something and add 1 of something, that's 3 of something, right? Similarly, if I have 2 cubed to 8 of something plus 4 of something, that's 12 of something, right? And then lastly, if I have 8 of something plus 2 of something, that's 10 somethings. So I'll just like 10. So we have, so I'll just write this out now so you guys can see how it looks like. So you have 3 times 16 squared plus 12 times 16 to the 1st plus 10 times 16 to the 0th. And that is in base 16. So we have 3, 12, 10, which is 3, C, and A. So 3CA is the answer. Okay. The next problem is just base 15 multiplication. So you can do, these numbers are fairly small. So if you want to do your converting to base 10 and converting back, you can. But obviously we want to work on efficiency. And also when you do it on like in a different base, you kind of like, you always want to train with the method that's like hard. So you build good practice with that. So A8, 3D, I multiply. For multiplication, I really like to just write it out. So like for example, like 8 times D, well that's 8 times 10, 11, 12, 13. So 8 times 13. That is in base, okay, so 8 times 13 normally is just 104. 104 in base 10 is equal to 90 is a multiple of, wait, why am I struggling to do addition? Yeah, if 90 is, yeah, no, 105 is a multiple of 15, and that's 7. So 90 is 6. So this would be 6 and 14. which is equal to 6, and then e in base 15. So the e goes here, and the 6 gets carried over. So now I'm going to erase this work just because I'm on a whiteboard. Probably don't waste time erasing it if you're doing it on a test. A times d is just 10 times 14. No, sorry, 13. Which is 130 in base 10. Plus a, no, yeah, 130 in base 10 plus, so 120 is a multiple of that. So 6, 7, 8. 8 times 15 is 120, so that's just 8a plus, so that's 8a in base 15, plus the 6 that we carried over. So that goes from 10 to 9, and I believe it's just, yeah, 9 and then just a 1, right? What I feel like that's wrong. No, yeah, that's right, because, yeah, that is right. Okay, so now we throw a 1 here, and then we carry over the 9, so, yeah, 9. Now, throwing a 0 here, because that is how we do 2-digit multiplication. 3 times 8 is 24. That's a lot easier to do in my head with base 15. So that's 24 base 10, that is 19 in base 15. Okay. Now, that's just going to be a 9 here, and a 1 gets carried over. Lastly, we have 30 in base 10, which is 20 in base 15, plus the 1 is 21 in base 15. Nice, we are nearly there. So adding them, we get e. 9 plus 1 is 10, so that's a in base 15, same here, and then a 2. So 2ae, or 2aae is your answer. Okay. Now we get some fun algebra. So that's pretty, like, I'd rather do the algebra problems than the base ones, because if you see me, like, I'm not too good with arithmetic in my head. So yeah, that's kind of like, especially why. So 23 in base x is just 2x plus 3 plus equals 3y plus 2, right? Just expanding them out in bases. So 2x plus 1 is equal to 3y. Now, these are our conditions, which is kind of given to us anyways, but I'm happy they wrote this out so it didn't like trip anybody up. But if we let x equal 4, does it work? Yes, it does. 4 comma, do I even need to write the y? I mean, y is 3. Oh wait, no, I need to acknowledge the y, because 4, 3 is not a solution, right? So yeah, 4, 3 is bad. So now I'm going to increase by something. I don't know what I'm going to increase by, but it has to be a multiple of 3. Alternatively, I could keep, actually, it's better to increase the y. It's better to like control the y and have the x be the dependent variable, because I can tell a lot easier if something, because 2x plus 1 is guaranteed to be an odd number. Therefore, y must be an odd number, right? Because this is even, and then an even plus an odd results in an odd. And then an odd times an even, and if y is even, then this whole thing becomes even. So 3y must be odd. Therefore, y must be odd, right? So that's kind of like some quick proof reasoning for you on why it's easier to do that, because I'm a lot easier at telling if a number is divisible by 2 because it's even or odd versus 3. So now if I let y be the lowest odd number, 5, that would work. That would yield some solution. The only reason I'm caring about the solution is because it needs to be in the range. So 15, 14, 7, yeah, works, perfect. Now, I can increase y by 2, 7. I can increase y all the way up until 15, right? The dot means just all the solutions in between. The reason I'm testing the last one is because if I know 15 works, then it's pretty nice, because, or wait, 15, why does that seem wrong? 45, 44, 22. So that doesn't work. So this would be 22, which is bad. So I'm just going to erase this. I guess I'll just write out all the possible cases. So you have 9, 11, 13. 13 is 39, minus 1 is 38, which is 19, so that's wrong. 11 would give 33. 32 is 16. Okay, that's cool because 16 is allowed. And then therefore, if your lowest value works and your highest value works, all these in between values will work too. I don't even need to know what these are. I just know that 1, 2, 3, 4. 4 is your answer. So yeah, I don't even need to know what the middle ones are. I'm like gonna guarantee you they work. Kind of because it's like the intermediate values. So yeah. Okay. Next problem. Okay, this one's nice. I kind of did. I don't know how good of a job I did last time explaining it. I'll hopefully do better. But yeah. Oh, sorry. One sec. I don't have a bite of this chocolate. I got chocolate from someplace, so pretty nice. Okay. Okay. So, time to do the problem. So, when you're adding columns, you gotta treat it like a little addition problem. So like 6 plus y, y plus x, 3 plus 2, whatever, right? So, you have 6 plus y. You have the case 1, where you carry over, right? Like, or I'll say no carry. You have case 2, where you carry, right? If you don't carry, then 6 plus y literally just equals digit x. Then y plus x does equal 3? No, because this you clearly do carry. You clearly carry a 1 over here. So therefore, y plus x just equals 13 in base 9, right? Base 9 is the one you're doing it, yeah. Right, and then x equals x. So yeah, this is the first case, right? Case 1 is no carry. Case 1 where you do carry, 6 plus y is equal to x plus whatever you're carrying over, which is a 1 digit, which in base 9 is 9, right? Because you're carrying over a 10 in base 9, which is equal to 9 in base 10, right? Now I'm trying to do all my algebra in base 10 because it's easier to work with. Then since you're carrying over, 1 plus y plus x is equal to 13 base 9, right? So that's 2 cases. Is there another case? No, because y plus x is guaranteed to carry, and then that makes life easier. So I'm going to simplify a bit. 6 plus y is equal to x. Y plus x is equal to 9 plus 3, 12. Here, negative x plus y is equal to 3. Y plus x is equal to 12 minus 1, which is 11, right? So now, why do I? Well, I have 2 different equations. Probably going to deal out 2 different x-y pairs. How do I know which one's the right one? Well, think of it. Number bases always have to be integers, and they have to be in the range, right? So if I get something wrong, or if I get something suspicious, I'm like, okay, well, wait a minute, something's not right. So I can like realize that that's an extraneous solution. So over here, I'm gonna do a bit of rearranging. Just so, yeah. Right? Yeah. Okay, so adding these equations give you 2y equals 6, y is equal to 3. Okay, cool. Sounds reasonable. Therefore, plugging into 3 plus x equals 12, x equals 9. Hold up. Can x equal 9? No, it can't, because we're in base 9. No digit can equal 9. Then you would have to carry over that digit. It makes no sense, right? So therefore, case 1 is bad. I'll even do this in a red pen, so bad. Right? Now, case 2 must be the only other valid case, or we did something wrong, but yeah, case 2 is the only one that works. So adding these up, 2y is equal to 14, y equals 7, okay, that works. Y plus x, or no, sorry, 7 plus x equals 11. Whoa, x equals 4, that also works. So therefore, the ordered pair is 4, 7. Okay, cool. I'm gonna have more of my chocolate. Okay, this one is a really nice problem. So One second, my brother's texting me. Sorry. Okay. So yeah, sorry, my brother just texted me, but okay. Now, before we even get into this problem, you gotta consider something. How do I convert a normal base or infinite repeating fraction into or infinite repeating decimal into a fraction? Sounds complicated, right? Like if I gave you what is 0.39 repeating as a fraction, the normal method that you would usually see in a math competition looks pretty jank, but it's actually pretty cool. You let this equal to x, right? Then multiply it by 100, right? So you shift it two digits to the right. And then it's a pretty intuitive method because now if you subtract them, right? This is equal to 39 plus 0.39 repeating, right? This is equal to 0 plus 0.39 repeating, right? Subtracting the two cancels these out. So you're left with 99x, right? 100x minus x is 99x is equal to 39. Therefore, x, which is denoted as this, is also equal 39 over 99. Very, very cool. Now, how does that influence this problem? Well, first of all, remember, B is 11, A is 10. So, yeah. So now, 0.2 BA repeating. I'm going to let that equal to x, right? How do I shift, and this is on base 12, right? So, first of all, I want to shift it such that I get these fractions to cancel out. One idea is having 2BA dot BA repeating, and then BA, or no, A, no, sorry, 2 dot BA repeating, right? Subtract these, this will cancel. So now let's do that. How do I shift the digit? In base 12, I'm going to multiply by 1,000 in base 12. So 1,000 base 12 times x is equal to 2BA dot BA repeating. And then 10 in base 12 times x is equal to 2 dot BA repeating. Subtracting these, this cancels out. Very, very nice. I'm gonna write this as this, just because I'll show you why in a second, but yeah, and then 2BA in base 12 minus 2 in base 12. Everything's in base 12. The reason I'm writing this as separately is because I'd rather because when I'm converting, because now I need to show what x is in base 10. I can convert it pretty easily because 12 in 1,000 in base 12 is 1728. Because of 144 times 12, right? No. Yeah, 1728 x minus 12x, right? And then after you get to this point, you're going to realize that, hey, why did I not do whatever this would be? This would be like 11. Like if I just did this in base 12, it would be like 11, 11, 0, right? Like that's just like more multiplication for me. So I left it like that. Now, this is just 1728 minus 12 is just 1716 is equal to 2BA, so 2 times 144 plus 11 times 12 plus 10 minus 2. So yeah, 288 plus 132 plus 8. So now x is just equal to 288 plus 140 over 1716. Now this is just a game of simplifying a fraction, or simplifying a fraction. But yeah, I don't want to show the gory algebra in the video. I'm just gonna do it real quick on my calculator just to make sure I didn't lie to you guys and say that this was the right fraction. So this should simplify to, yes, okay. So this is the right fraction. Okay, so x is just equal to 107 over 429, which is just your final answer. So very cool. So yeah, those are all the problems. But yeah,